All right, so number 68, assume that the probability of the birth of a child of a particular sex is 50%. So whether you get a boy or a girl, it's 50-50. Okay? In a family with 4 children, what are the probabilities that all the children are boys? Okay, what's the probability the first one is a boy? 1/2. Second one, 1/2. Third one, 1/2. Fourth one, 1/2. So 1/2 to the fourth, or 1/16. All right, so that's part A. Part B, all the children are the same sex. So all of them are boys, or all of them are girls. Okay, all the children are the same sex. So all are boys or all are girls. Well, the probability, that's probability of A or probability of B. The probability of A is 1/16. The probability of B is again 1/16. Okay, are these mutually exclusive? If they are, the probability of A or B is going to equal the probability of A plus the probability of B. So 2/16 or 1/8. Now, why are they mutually exclusive? Because you can't have the probability that all boys happens at the same time as the probability that all girls happen. Either one could happen or the other, but they both can't happen at the same time. That's mutually exclusive. If these aren't mutually exclusive, you would want to use this formula, right? But this is going to be 0, so you don't need that part. So your answer here is 1/8. Okay, the next one. There is at least one boy. Okay, part C, there's at least one boy. So what does that mean? All right, well, that's actually a pretty tough thing to find, the probability that you have at least one boy. Because you'd have to find the probability that you get 4 boys. Boy, 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 boy. The probability you get 3 boys, so girl, boy, 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 girl, boy, 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 girl, boy, 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 girl. And then the probability you get 2 girls, okay, so girl, girl, boy, boy. And so I'm not going to list all of these. Like I said, this is a difficult problem to do. But the opposite of at least one boy is really easy to do. Okay? So, but you have to wrap your hands around it. So either I have one boy or more, or I have the opposite. Okay? And this is what we're looking for. This is tough to find. This is easy to find. But what is it? Well, what's the only situation where you don't have at least one boy? I want you to pause the video and think about that. When can you have the opposite of at least one boy? Okay, the only time that you're not going to be, like if you have a Venn diagram, okay, either this is happening or this is at least one boy. What's the only thing that's going to be in here? Well, this is only going to be it's only going to be the opposite of this if you have all girls. Okay, this is the only situation where you don't have at least one boy or more. Well, what's the probability of all girls? 1/16. So the opposite of 1/16, what's the probability you have at least one boy? 15/16. So if you have 4 kids, when you get to be about 25 or 30, if you have 4 kids, the probability that you're going to have at least one boy is 15/16. The probability you have all girls, 1/16.